Next problem is 2129. It's a very easy problem that I want you to be sure that you know how to do it. Any vector r can be written like, you see this direction, this is the direction of the vector r. So it exists a vector that I will call r with the cap, unitary vector. And the unitary vector, if you make it like this, r times the magnitude of the vector r in the direction of r, you will fill the vector r. So the vector r will be, if the magnitude of r is 5, 5 times 1 in the direction of this direction will fill the vector. So I hope that you can realize that the vector r is simple. The vector r with the cap, the unitary vector, is the vector r divided by the magnitude of r. And this is what we are going to apply in these cases. So for the part A, it say the part A, where is the part A? X equals 0, y equals minus 1.35. So I don't have to calculate anything. The vector r will be the vector minus j. The vector r with the cap, the unitary vector, is the vector that has magnitude 1 and direction minus j. So the first part is done. The second part, when x equals 12 and y equals 12, it means that you are talking through a point, let's say 12 centimeters. Let's go to talking centimeters. Okay, 12 and 12, so it means that the vector is here. This is the vector r. So this is 12 by 10 a la minus 2. And this is 12 by 10 a la minus 2. So this is the vector r. So I wrote the vector r. This is the vector r. And the unitary vector, the vector that is on the direction of r, this is r. This is the vector r. I'm looking for a vector that has this direction. By the way, this direction is 45 degrees. I know because this distance is the same than this distance, so it should be 45 degrees. So I'm looking for a vector r that has magnitude 1 and is on the direction of the vector r. So the unitary vector r with the cap will be the vector r divided by the magnitude of r. So if you make the calculation, you will find that the vector unitary will be this vector. And you can find the magnitude of r, and you can see that this is 1 really. And if you see in what angle is the vector unitary, you will see that it's also at theta equal 45 degrees, like the vector r, so you can change. And the second part is when you change the point. So now you change the point. The position is x equal minus 10 and y equal 2.6. So the vector r will be this vector r. The magnitude of the vector r you calculate. I'm not going to calculate. So again, you have to make the same calculation. You make the vector r divided by the magnitude of r. If the magnitude of r is 10.3, okay, whatever, I don't, this is meter, okay, yes, should be 10. Okay, around the square root of something. Okay, you make this calculation. So the vector, the unitary vector in the direction of the vector r that have the magnitude 1 will be this vector. The vector minus 10i plus 2.6j divided by the magnitude of r that I said should be around 10.3. And again, if you draw these vectors, it says that the vector is minus 10i. Minus 10i, 1, 2, 3, 4, 5, let's say minus 10. minus 10 in the I direction. And later you say 2.6, 1, 2, and 0.6. 2.6, 2.6, oh, positive, so we go up. 1, 2, and 2.6 in the J direction. So the vector R is this vector. This is the vector R. And the vector that we are calculating, this vector, is the vector R with the cap. It has the same direction, but it has magnitude 1. So you calculate again. And you will check again that the magnitude of R, once that you calculate it, should be 1. So it will be minus 10 divided by, I'm not sure, 10.3, you calculate to be I plus 2.6 divided by 10.3 in the J direction, and this is the vector R, and you calculate this square plus this square, it will take 1. So it's easy, no problem. Let's go to the next problem.